going to be talking today about inferences about two population proportions. A sampling method is independent when the individuals selected for one sample do not dictate the individuals who are to be in the second sample. A sampling method is dependent, also known as match pairs, when the individuals selected to be in one sample are used to determine the individuals in the second sample. We still have these requirements. They have to be obtained independently by simple random sampling, or the data comes from a randomized experiment. Number 2, N1 P1 times Q1 is greater than or equal to 10, and N2 P2 Q2 is greater than or equal to 10. Sample size is no more than 5% of the population. So now instead of just one set of data, we have two. So if notice there's a P1, N1, X1, and this is the point estimate for P1. And then a population for population 2, P2, N2, X2, and a point estimate for population 2. Your hypothesis is very similar, P1 equal P2. Your null is P1 is not equal to P2, P1 is greater than P2, or P1 is less than P2. Notice that we are only going to be concerned about the test statistic and about the p-value. So that's how we're going to make our decisions on our p-value. In October of 1947, the Gallup organization surveyed 1,100 adult Americans and asked, do you totally abstain from drinking alcoholic beverages? 407 said yes. In July 2010, the same question was asked of 1,100 adult Americans, and 333 said yes. Has the proportion of adult Americans who totally abstain from alcohol changed? Use 0.05 level. Changed is not equal to. So what we have is we have X1 and M1, X2 and N2. So we'll let X1 be the first set of data. So that will be 407, 1,100. X2 will be the second set of data, 333, 1,100. Then we will decide how to write our null and alternative hypotheses. So the null hypothesis is P1 equal P2. Remember, it's always equal. P for proportion. Your alternative is P1 is not equal to P2 because it's changed. And your level is given right here. Alpha is 0.05. Using your calculator, Z is equal to 3.34. P is equal to 8.4 times 10 to the negative 4. Now, if we write this in scientific notation, that's 1, 2, 3, 4. That was scientific notation. Writing it in as a numerical value gives you this. So we're going to say which is approximately 0.0008. So how does P compare to alpha? If it's less than, you reject. So we're asking ourselves. So is 0.0008 less than 0.05? Yes, so we are going to reject HO. There is sufficient evidence to conclude or to support the claim that P1 does not equal to P2. We could also put it in words. We'll do that in the next example. Example. In a study of red-green color blindness, 500 men and 2,100 women were randomly selected and tested. Among the men, 45 demonstrated color blindness. Among the women, 6 demonstrated color blindness. Is there sufficient evidence at alpha equal to 0.05 to support the claim that men have a higher rate of red-green color blindness than women? Okay, so let's do men and women. Just to keep our data easy to follow. So we'll do men and women. Usually I see whatever comes first. I use that as the X1 and the N1. So men, X1 is 45, N1 is 500. For women, X2 is 6, N2 is 2100. Okay, so your null hypothesis is P1 equal P2. Your alternative is P1 is greater than P2. Alpha is equal to 0.05. Again, using your calculator, remember it's for two proportion z-test. We get z is 12.63. P is 7.63 times 10 to the negative 37. Now that's scientific notation. That means we would move our decimal point to the left 37 places. So we're going to say that this is approximately 0. So how does 0 compare to 0.05? 0 is smaller. Reject HO. So let's look at how we would write a conclusion using the words from the problem. Reject HO means there is sufficient evidence to support the claim that men have a higher rate of red-green color blindness than women. Now, another way to write your answer would be P1 is greater than P2. All right, so let's look at using intervals, confidence intervals. All right, when you calculate a confidence interval in this chapter and a confidence interval of the difference between the two parameters, there are 3 possible outcomes. So both of the signs for the numbers in the interval, the lower bound and upper bound, can be negative. Okay, that means there is a significant difference between the values if they're both negative. They could both be positive. There is a significant difference between the values. But notice if the signs are opposite, you have a negative and a positive. Okay, there is not a significant difference. That's one way. So this is one way to test it. Now, the other way is to ask yourself, is 0 in the confidence interval or not? If the confidence interval contains 0, there is no significant difference. Okay, if it does not contain 0, there is a significant difference. So again, we'll have to test it and see what type of numbers we get in our interval. What are the signs of the numbers? The body mass index is one measure that is used to judge whether an individual is overweight or not. A BMI between 20 and 25 indicates that one is at normal weight. In a survey of 750 men and 750 women, the Gallup organization found that 203 men and 270 women were normal weight. Construct a 90% confidence interval to estimate the difference of the two proportions. Based on the result, does there appear to be a significant difference in the proportion of men and women who are of normal weight? So again, let's decide and kind of label what we know. Write down what we know, men and women. So we need an X1, N1, X2, and N2. Your confidence level is 0.90. So let's see, the total number of men, they start there, 750 men, 750 women. Men is 203, women 270. Okay, so if we use our graphing calculator, Okay, notice the keystrokes, stat, test, 2prop-z. This is the letter B. That's a little bit hard to read. So you arrow all the way down to B. And what we get is we get a confidence interval of negative 0.1286, negative 0.05. Notice your signs are both negative. It says there is a significant difference. So if the signs are the same, there is a significant difference in the proportion of men and women who are normal weight. Okay, among 5,000 items of randomly selected baggage handled by American Airlines, 22 were lost. Among 4,000 items of randomly selected baggage handled by Delta Airlines, 15 were lost. Use the sample data to construct a 95% confidence interval estimate of the difference between the two rates of lost baggage. Based on the result, there appear to be a significant difference in the lost luggage rate? Okay, so you have American, you have Delta. Again, we've got X1, N1, X2, N2. So X1, let's see, 22 were lost by American out of 5,000. 15 were lost by Delta out of 4,000. Again, using stat, test, 2prop-z interval, we are going to get negative 0.002, 0.00329. And it'll always be negative and positive because this is like a number line. Okay, negative is always on the left, positive is on the right. Okay, because it's negative, positive, if I look at what I circled here, there is not a significant difference. Also, 0 is in here. Okay, so that's a look at the two population proportions.